Hello and welcome back. In this tutorial, we will differentiate product and quotient of two functions. So if we have product of two functions, function u times function v, and we wanted to take derivative of these two functions, this is the formula. So first we differentiate first multiplier times the function v itself plus derivative of function v times function u itself. For the quotient rule, we have the following formula. If we divide in function u by function v, derivative. The formula is, first we take derivative of the numerator, function u, times function v itself, minus derivative of denominator, v prime, times function u, everything divided by denominator squared. These are formulas which we will be using today. Let us do some examples now. Let me differentiate product of the following functions. X minus 4 times natural logarithm of x. So when I look closely at this function, I can see product here. Right away, I understand that I have to use a product rule. I have to denote one function by u and another function by v. And now what I do, I just rewrite in my formula for the product rule, but with my particular functions, u and v. So it will be equal to u prime, and I'm just rewriting whatever I have under u derivative, times function v, times my function v, plus now v prime, so I'm just rewriting my function, logarithm of x prime, times function u, which is x minus 4. So I didn't do any math yet. I just rewrote my formula for the product rule with my particular functions u and v. Now we start to differentiate. Usually I do it separately in order to avoid mistakes. So let's find derivative separately for function u and for function v. U prime derivative, which is just x minus 4 prime. It will be x derivative minus 4 derivative. Derivative of constant is always 0, and derivative of x is just 1. So derivative of function u is just 1. Now, derivative of function v is just derivative of natural logarithm. And we know from formula that this is 1 over x. Once we know derivatives of u and v, we can plug it in back into our formula to obtain the result. So we have 1 times natural logarithm of x plus 1 over x times x minus 4. Here we go. This is the derivative of the product of two functions. Let us do one more example on product rule. Let me differentiate the following functions. E to the power of 3x times, and now I put polynomial here, 3x squared minus square root of x and plus 1. Again, I have product here, so I have to use product rule. First function I will denote by u, and second function I will denote by v. And now I just rewrite my formula for the product rule with my particular functions u and v. So I have u prime, which is e to the power 3x prime, times v. I'm just rewriting my function v, plus v prime so my function v derivative times u. And now separately I would find derivatives of function u and v. So u derivative, which is just exponential function derivative, and it's equal to 3 times e to the power of 3x. And derivative of function v is the derivative of this sum and difference of the functions. So I have to split them into 3 functions. And we have 3 times derivative of x squared is just 2x minus half x to the power of negative half plus 0, because derivative of constant is 0. Now we are ready to plug in our derivatives back to the formula. So derivative of the product will be equal to derivative of u, we just found it, 3 e to the power of 3x times function v plus derivative of function v, which is this, times function u. And this is our answer. Let us now differentiate quotient of two functions. 4 times natural logarithm of x divided by x cubed. I have division of two functions. So numerator, I will denote by u, and denominator, I would denote by v. So we have exactly this formula u divided by v. And we wanted to differentiate it. Again, as before, I would rewrite my formula, quotient rule, for my particular u and v. So it would be equal to u prime, which is 4 logarithm x derivative, times v, x cubed, minus v prime, which is x cubed prime, times u, which is 4 logarithm x, everything divided by whatever in denominator squared. Now again, separately I would find derivatives of u and v. U prime, it's just derivative of logarithm, and 4 we can bring outside of the differentiation, so we have just 4 over x. And derivative of v is just our formula x to the power of n, so it's 3x squared. Now we are ready to plug it in into our function. So it will be equal to derivative of logarithm 4 divided by x times x cubed minus derivative of v, 3x squared times 4 times logarithm of x, everything divided by x cubed to the power of 2. I just multiply and powers over, so I have x to the power of 6. And this is our result. Now it's your turn to practice.